Dear students and viewers, let us continue with the last class section on valency and how to find the valency of the elements to form the compounds. As I explained in the previous class, elements will try to reach the stable octet arrangement. They want to become more stable, and hence they react with the others. And as well as in the last class, we had seen few examples how to find the valency of elements like carbon, aluminum, and chlorine, etc. So now let us try to evaluate to find the valency of first 20 elements. Okay, after that we'll try to go with the chemical reactions. Okay, let us start with the hydrogen. So the hydrogen, the second element is helium, lithium, beryllium, boron. So I have written in the increasing atomic number. So its atomic number is 1, 2, 3, 4, 5. So here we can see this helium is a inert gas. So now the hydrogen will try to attain the structure like helium, even though the helium doesn't have octet arrangement, but it has a stable configuration. So the hydrogen will try to attain the configuration of lithium. And we can see here carbon, then followed by nitrogen, oxygen, and fluorine is neon. Sorry, fluorine is 9 and neon is 10. And sodium is 11. Magnesium is 12. So let us go with up to 12. Then we'll come ahead once again. So the atomic number of hydrogen is 1, which means the atomic number of hydrogen is 1, which means it has 1 electron and 1 proton. So we have already seen here, proton is 1. There's no neutron. And in the first orbit, it can even have 2 electrons, but we are going to have only 1 electron. So if you want to attain the stable configuration like helium, because helium is a stable configuration, it has to gain actually 1 electron. It has to gain 1 electron. So the valency of hydrogen is what? 1. Or in another layman term, the valency definition is the number of electrons in the outermost orbital. So this is the outermost cell. We can see the number of electrons is 1, and hence the valency of hydrogen is 1. So I can write 1. This is nothing but my atomic number. This is not the valency, it is the atomic number. What is the valency of helium? 0. Why it is 0? Because helium has 2 protons, 2 neutrons, and 2 electrons. So this orbit can have a maximum of only 2 electrons, because the k orbit, it can have a maximum of only 2 electrons. Now it also have 2. So there's no need of this helium atom to either lose the electrons or to gain the electrons. It is already satisfied. It is stable. It is noble gas. It is a noble gas. So what is valency? It will not react with any other gas. So its valency is 0. Yeah. So let us now continue with lithium element. The atomic number of lithium is 3. So we can see the number of protons is 3. Neutrons is actually 4 because the mass number is 7. And hence the first orbit can have, the number of electrons will also be 3. The first 2 electrons will be here. The next electron will be here. So in the k orbit we can find 2 electrons are there. Even though the L can have up to 8 electrons, but here we are having only 1 electron. So now to attain octet, it's not required to attain octet. Even it can become like helium. The lithium also will try to become helium by leaving 1 electron. So as otherwise I told you the layman term, the number of electrons in the outermost orbit. Here the number of electrons in the outermost orbit is what? 1. So the valence is 1. So we can see that the valence of hydrogen and lithium are 1. Here the hydrogen needs 1 electron, where the lithium needs to give 1 electron. That's the only difference. But both have a valency of what? 1. So when you're going for the next case of beryllium, we can see what will happen for beryllium. So beryllium is atomic number is 4. So the number of protons will be 4. Okay. Here it will be neutrons will be 5. So here the first orbit will have 2 electrons. The next orbit will also have what? 2 electrons. So the number of electrons in the outermost orbit is what? 2. Or it has to give 2 electrons outside, so that it will become like helium. So that it will become like what? Helium. So here there is no need to write. Just you can follow me. So he can see it's 0, 1, 2. So the next valence will be what? 3. The next valence will be what? 4. So for nitrogen it will become 5. Don't write 5. You can subtract 8 from the, if the number exceeds 4, you subtract from 8. Whether I'm clear? I'll repeat once again. I hope you'll be able to get the valence very easily. For hydrogen, we know it's 1. From helium, it is 0. Lithium 1. Beryllium 2. Boron 3. Carbon 4. When it comes to nitrogen, don't put the valence as 5 because the number is increasing. We thought of putting 5. But subtract that 5 from 8. So we'll get how much? 3. Which means your valence should not go beyond 4 except phosphorus. Expect what? There's also some condition. Expect phosphorus. I'm giving some lazy tricks, small tricks, which is not appropriate, but it's easy to recall. So we can see the valence of nitrogen is 3. So what is the valence of oxygen? 2. Okay. So what is the valence of fluorine? 1. The valence of neon is 0. Okay. Got the logic? So this is the way how to proceed. If you want to explain nitrogen, why it is 3, I will explain you like this. Nitrogen atomic number is 7, which means number of protons is 7. Neutron is also 7. First orbit is 2 electrons is there. The second orbit is how much? 5. So in order to attain stable octet arrangement, it has to gain 3 electrons. So the valence is 3. So anyway it will come. So don't worry. We can also go by the complete theory. So we can also get it. Whatever we are getting from K orbit, L orbit, M orbit, N orbit also is not 100% correct. It's only way. Actually, we have to go with the suborbitals like SPDF. That will go in future, but right as of now, it's right. Right as of now, this is the easiest way of getting the valency. Or the atomic number of oxygen is 8, which means there are 8 electrons. I am not writing the nucleus. So the first orbit 2 electrons. Second orbit how many electrons? 6. So how many electrons needed to become octet? 2. So the valency is 2. So coming to fluorine, first orbit is 2, second orbit is 7. Still one more electron is needed. So the what? 1. So neon is what? 0. Why neon is 0? First orbit 2, second orbit is 8. Already is octet. So now helium and neon comes under the inert gases, rare gases. So they won't react with others. Already they are stable. So every other elements will try to become either like helium or neon. So we can see this hydrogen, lithium, beryllium, boron and all will try to become like helium. This carbon, nitrogen, oxygen, fluorine, sodium, magnesium, aluminum and all will try to come like a neon. Got the logic? So what I'm telling means, it is easily you can write like this. So from lithium, you know the valence of hydrogen is 1. Helium is 0. Then you write 1, 2, 3, 4. Don't go beyond 4. Once again you come down. 3, 2, 1, 0. Once again what is the number then? 1, 2, 3, 4. Very good. So now we can say sodium is 1. You can also cross check. Magnesium is 2. Aluminum is what? In the morning we derived. Aluminum is 3. Silicon is what? 4. Phosphorus is what? 5. I told not to put 5. You can subtract from 8 and put 3 aspect phosphorus. So phosphorus has divalency. It has both valences 3 and 5. It has both the valences 3 and 5. Let us discuss this afterwards. Now let us say it has both valences of 3 and 5. Then sulfur. Sulfur is, let us come down. This valence is 3, 4. So once again I am coming down. Okay, so from 4 to 3. Then 3, 2. Sulfur. Then chlorine. What is the valence of chlorine? 1. What is the valence of argon? Why it is 0? Noble gas. So once again it should follow like this. Okay, it's a 0. Once again what should happen? Yeah, it should increase. K. So what is the valency? 1. What is magnesium? It is not magnesium, sorry, it's calcium. Magnesium is already there. So calcium is what? 2. Okay, then we will follow with scandium, titanium, vanadium, etc. But at least these 20 elements you should know. So if you want to cross check also, we can cross check. Morning also we cross check chlorine. Let us take sulfur. Sulfur atomic number is what? 16. So first orbit is 2. Second orbit is 8. Okay, I am not drawing fully. 8. So 10. The remaining is what? 6. So in order to octet, it has to gain 2 electrons. So the valence is 2. So now I know the valency of every compound. Every element starting from atomic number 1 to 20. It is more than sufficient. Now, what is the formula for hydrochloric acid? HCl. So everyone knows the formula for hydrochloric acid is what? HCl is hydrochloric acid, HCl. Otherwise, this is also called as what? This what is another name of this one? This hydrochloric acid. What is this common name? If it's not an acid. You are telling this as hydrochloric acid. I don't want to name it as acid. Then how will you call this? That's it. Hydrogen chloride. Hydrogen chlorine come into the form. Hydrogen chloride. So you have to see as an acid as a normal thing. And here, what is the valency of hydrogen? 1. What will be the valency of chlorine?
1.
No, you know earlier, because we have derived the valency of chlorine is 1. But already everybody know the valency of hydrogen is 1. Which means, here what is the number? There is no number. Here also there is no number, which means 1, 1. Which means the chlorine should have 1. Then only when I cross multiply will be like this, isn't it? Then only I can put a H1Cl1. So HCl. Which means I am telling, if you are knowing the valency of hydrogen, you can find the valency of chlorine indirectly. There's no need to go for checking the answer. Because you know the valency of hydrogen is what? 1. You also know the formula for hydrochloric acid is what? HCl. So from that I am telling the valency of chlorine is what? 1. Shall I repeat it? Okay, I'll repeat once again. You may not be, I may be fast. Now you take, what is the formula for sulfuric acid? H2? SO4. What is its common name? What is common name? Hydrogen sulfate. Very good. This common name is hydrogen sulfate. Now, I want to know what is the valency of sulfate. I want to know what is the valency of sulfate group, not sulfur, not oxygen. We know the valency of oxygen is what? 2. We know the valency of sulfur is what? 2. But I want to know the valency of sulfate group. I want to find the valency of the group. Now, what does this 2 indicates? How these 2 might came? How these 2 might came?
Because the valency of SO4
is 2. Very good. The valency. So how it may came means here the top of SO4 it should be 2. The top of hydrogen should be what? We know valency of hydrogen is 1. So you cross multiply. So you got what? H2SO4 1. But it's not required to write the SO4 one time. So it's what? So what is the valency of sulfate group?
2.
2. The valency of sulfate group is what? 2. That's very simple. So like this, from the known one which you know already, you know the formula for sulfuric acid is what? H2SO4. From this, I'm able to derive the valency of what? The sulfate group. Okay, whether I'm right? It's easy to understand. So this is another way of finding the answers. These are some short tricks. Now, what is nitric acid? HNO3. What is the common name? Hydrogen nitrate. Hydrogen nitrate. Now, what is here? 1. What is here? 1. Which means how this formula came? What is the valency of NO3 group, nitrate group? 1. What is the valency of hydrogen? 1. So you cross multiply. So it is H1, NO3, 1. So from the known facts, whatever we know the formula for nitric acid is HNO3. We know the formula for sulfuric acid is H2SO4. Okay, yeah, fine. Now, let us go with another acid. Do you know this acid?
Hydrogen carbon.
Hydrogen carbon is common name. What is the acid?
Carbonic acid.
This is called carbonic acid. This acid is called what? Carbonic acid. Can you think how this acid may be formed? This is an acid. How this acid may be formed? This acid is formed by mixing water with carbon dioxide. Water and carbon dioxide. So you can see H2. One oxygen will combine with this CO2 to form what? H2CO3. Water plus carbon dioxide gives carbonic acid. This acid is called what? Carbonic. Okay, this cell balanced. Now what will be my question? From this, what is the valency of CO3? What is the valency of CO3? What is the valency of hydrogen? 1 we know already. So what is the valency of CO3 now? 2. Because if this 2 was here only, when I cross multiply it will come. So the valency of CO3 group, carbonate group is 2. Got it? So now you are able to get the valency of the groups. Earlier we found the valency of the individual elements. Then now we are trying to find the valency of the groups. Okay. Okay. Now, based on the valency of hydrogen, we are able to find the valency of nitrate group, NO3. We are able to find the valency of CO3 group, carbonate group, a sulfate group, SO4, like chlorine, etc. Now, I will repeat once again. Not repeat means now I am just writing the formulas. H2SO4, HNO3, H2CO3. There's one more acid. This acid you may not be knowing. Today only you may be knowing. Maybe some of you knowing, but carbonic acid generally the students won't know. There's one more acid. Can you tell what is phosphoric acid?
HPO.
Yeah, you are right. H3PO4. This is phosphoric acid. Now, what is the question? What is the answer?
The valence of PO4.
Yeah, the answer of the phosphoric group is what? 3. What is the answer of hydrogen? 1. So I don't want to bore you. I hope you got it. Very good. So this is phosphoric group. This is phosphoric acid. This is carbonic acid. This is nitric acid. This is sulfuric acid. This is hydrochloric acid. Why we are calling all this as an acid? This is the question for you now. Why? This is hydrochloric acid. This is sulfuric acid. This is nitric acid. This is carbonic acid. This is phosphoric acid. I don't know other acids. Okay, I can put H3PO3 is phosphorus acid.
Formic acid.
HCOH is formic acid, but that will come under carboxylic acid. Let us discuss that when we are dealing with organic chemistry. Now I want to have a why we are calling this as acid, which is common in all the terms.
Hydrogen.
That's it. So whenever there's a hydrogen, whenever there's no carbon, there are two conditions. Whenever there's no carbon, whenever there's no hydrogen, if the hydrogen is there, it's called as acid. It's called as what? Acid. In all these cases, hydrogen will have plus. The charge of the hydrogen will be what? Plus. So, okay, I'll tell why it is plus afterwards. But now we can consider this is what? H plus, which means Cl minus. Then only it is neutral. Even the compound should be neutral. Even the compound should not have any charge. So, all the acids have H plus ions. If there's H plus ions, it's called as acid. If there's H plus ions, it's called as what? Acid. Now, H2SO4. What is in this one? What is the value of hydrogen? What is the charge? 2 plus. Very good. What is the value of SO4? 2 minus. So, sulfate ion, even though it's 2 we are telling, but this is positive, this is what? Negative, so neutrally it will become 0. Here also plus 1, minus 1, 0. Here plus 2, minus 2, 0. Now coming to nitric acid. So what is the valency of hydrogen? Plus 1. What is the valency of nitrate? Minus 1. So becomes 0. And here it is what? Plus 2 is minus 2. Plus 3, minus 3. But it will be neutral. But all of them we are calling as acid because all will contain at least 1 H plus ion. Here there are 2 H plus ion. 1 H plus ion, 2 H plus ion. Here there are 3 H plus ion. But at least 1 H plus ion is what? Acid. If there is H plus, it's called what? Acid.
HF.
Huh?
HF.
H. Yeah, very good. We can also put a hydrogen fluoride. Hydrogen, like hydrochloric acid, hydrofluoric acid. This is what? Hydrofluoric acid. Here also plus 1, minus 1. The charge of hydrogen is plus 1. It is minus 1. Very good. When you are telling hydrogen fluoride, you can also tell what? Hydrogen? No. Hydrogen chloride you told. From that you told hydrogen fluoride. Very good. Hydrogen bromide. Hydrobromic acid. Hydroiodic acid. Why means all this one. Chlorine, bromine, fluorine, iodine. Okay. These are all called as halogens. These are all called as what? Halogens. So, if I'm writing HL means, as you told, it's understood. There's hydrofluoric acid. There's hydrobromic acid. There's hydroiodic acid. One more acid is also there. Hydroarsenic also will come under the halogens. But as of now, these are the 4 popular halogens. So, I agree. So, these also what? Acid only. These are also what? Acid. Why they are called as acid? Because H plus ion is there. Now, my question is, so I want to make it more interesting. When I'm telling H plus acid, what is the molecule should have to have base? Base is the opposite of acid. Base is the another name for the opposite of acid is base. The another name for base is what? Another name for base is what? Alkali. Alkali or alkaline? The solution is called as alkali. Generally, it's called as alkali. ALKALI. So acid, the formula should have what? H plus. Now I'm asking what should be the similar group for base?
Minus.
What is minus? H minus. And then? Yeah, it should be minus. Then here for acid we have H plus. Here it should have minus, but which minus? Now I'll ask you a question. I'll give you a clue, you will get the answer. Water, whether it's acid or base.
pH value more than 7.
I do not know. I am a small kid. I do not know I do not know what is pH value also. H2O is what? Water formula is what? H2O. Everybody knows the water formula is H2O. Now whether it's acid or base or neutral. Neutral. Which means H2O can be written as how we can write H2O in another way. The same thing I want to write in structural way. This is the molecular formula. Yeah.
Electron
No, no, within this one, this formula is called as what? Molecular formula.
OH. H
Ah.
plus OH.
Not O plus HOH.
OH.
HOH. So now what is the valency of H?
Plus.
Plus 1. What is the valency of OH?
Minus.
That's it. What is the valency of OH? Minus 1. Okay. Now you tell me what should be the compound should be present, or what should be the group should be present to make it as a base.
So at least minus.
Minus should be there, but I given the example clue also. The board is available.
OH.
Whenever there's OH group, it is called as base. Okay, so water is acid or base? It has both acid and base, so it's neutral. So it is what? So the very important, everybody knows that water is nothing but what? H2O. Got it? So H and OH. H and what? OH. So H is acid. OH is what? Base. So whether it's acid or base, no, nothing. It becomes neutral. It becomes neutral. So whenever hereafter you are going to find OH, your mind should strike, it is a base. It's a base. Got it? Instead of plus 1, you have to put minus 1. Instead of plus 1, you have to put as what? Minus 1. So can you give me an example of base now?
NaOH.
Very good. NaOH. What is OH? OH is minus 1. Instead of plus 1, you have to think as what? Minus 1. So what is the valence of sodium? That's it. So now there is no need to find hereafter the valence of sodium. NaOH is nothing but a base because sodium hydroxide. You also know sodium hydroxide. Hereafter, whenever you are seeing sodium hydroxide, you have to see as a base. What is the another formula of another base?
KOH.
KOH, potassium hydroxide. What is calcium hydroxide? CaOH twice. Okay, magnesium hydroxide, MgOH twice. Aluminum hydroxide, AlOH thrice. So all these things are called as what? All these things are called as what? Base. Why it is called as base? OH group is there. This OH is what? Minus 1. Which means, yeah, this is also minus 1. This is what?
2 minus.
It is minus 2, or as you told, it's 2 minus. That is, it contains 2 negative charges. So minus 2. It is minus 2 means what about this one?
Plus 2.
That's it. So there is no need to find the value of water, valence of calcium. If you know the formula of calcium hydroxide, if you know the formula for calcium hydroxide, you can tell the valence of calcium is what? 2. Because it has 2, so that only went here. OH is 1, it came here. What is the valence of magnesium? Plus 2. What is the valence of this one? Minus 2. Aluminum?
3 plus.
Yeah, plus 3 or 3 plus or plus 3, whatever may be. OH is minus. Only 1 minus, but there are 3 compounds, so minus 3. So whenever you are seeing hereafter OH, it is a base. Whenever you are going to see H plus, it's called what? Acid. That's it. So I hope it's easy. Now you are able to find the valency also. You can also cross check if you have doubt whether it will come as CaOH twice or CaOH thrice or CaOH. Then you can go for the basic formula, how to find the valency of calcium. Then you can do it. Okay, fine. Is that clear? Yeah. Now HCl is there. HCl is acid or base? Acid. Why?
H plus.
It has H plus ion. It has H plus ion and Cl minus ion. Cation, anion. Okay. H plus ion is called as cation. This T looks like what? Plus. So it's cation. So just to recall, chlorine ion is negative anion. Okay. So how to recall cation as positive? Because this T symbol looks like plus. So it is cation. Okay. Fine. Yeah. Now I am going to replace this K, H by K. What is the valency of a K then? Plus 1. Because hydrogen also 1, this also should be what? Plus 1. If I want to replace hydrogen with calcium, what will be here? What is the formula of calcium chloride? CaCl2. Why? Because calcium valence is 2, chlorine valence is 1. Okay, it's minus 1. So if you are going to multiply here, it will become Ca1, Cl2. So calcium chloride. So what? Calcium chloride. Okay, I hope we have covered what is acid and base. And one more equation is there. Acid plus base gives what, you know? No, it gives what the product. These are reactants. These are called as what? Water is there. Very good. Then water will be there. You are right. Salt plus water.
Yes, sir.
Acid plus gas is what? Salt plus water. Very good. These are products. Now, whether this side energy will be more or this side energy will be more.
Right side.
Right side energy will be less. Right side energy will be less. Reactance energy will be more. Okay, the right side energy will be less. That is called Gibbs free energy, but right now we are not going to discuss. Just an idea. Generally, the reactants have more energy than the products. So whenever you find delta H, it is nothing but a H of the products minus H of the reactants. H of the products minus H of the reactants. What is H? The heat energy, the enthalpy energy. Okay, that you study in future. Heat energy of the products minus heat of the reactors will be always negative. Will be always negative means what is the meaning? The enthalpy of the product is less than the enthalpy of the reactor. So the only is become negative. So only negative. So if you are not able to understand, leave it. Just an idea. Just an idea. The energy of the reactors will be more than the energy of the products. Okay. Why so? That is physical chemistry. That is what? So physical chemistry will be somewhat interesting if you are able to understand. Okay. Now acid. Can you give me an example of it? Acid. Hydrochloric. Can you give me a base?
Sodium hydroxide.
Sodium hydroxide. Sodium hydroxide. Now you see, this will be formed. NaCl plus H2O. So acid plus base gives salt plus water. So very simple thing. Okay. So this type of, so you know what is the reactant, what is the product. And generally it is a convention to put an aggregate downwards if it's going to get characterized as precipitate. It's going to get characterized as what? Precipitate. What is precipitate? If you're going to do some experiments and you in a test tube, let us say a test tube is there. Now I mixed it. After mixing, what will happen means this salt will get sedimented or precipitated at the bottom. You can see some white color things will be get scattered. The plain water will be above. Where the plain water will be, let us assume I am taking a test tube. I am pouring some hydrochloric acid. I am going to pour some sodium hydroxide. Then after some time, I am going to leave it. After some time, I can find that sodium chloride will be settled at the bottom. Clear water will be above. Okay, this causes precipitate. When it's going to get precipitated, it's always a symbol to put downwards. It's always a symbol to put what? Downwards. In some reaction, some of the gases may escape. Some of the gases may escape. Then it is a notation to indicate like arrowhead. Arrow means gas, we can't store it. It will go up. Solid means it will come, settle down. Okay. And if it's a liquid, I have to put as L. If a solid is here is not solid, but if it's solid, I have to put as S. If it's gas, I have to put either the upward arrow or gas. Sometimes they used to put AC. What is ACQ or AC? What is that? It is liquid with water. Aqueous solution. Okay, ACQ is something but what? Aqueous. Aqueous means what? Hydrochloric acid is there, but I'm not putting what? Liquid. I'm going to put aqueous. So what is the HCl aqueous and what is HCl liquid? What is the difference between these two?
With water, without.
Yeah, this is with water. Very good, very good. This is hydrochloric acid with water. This hydrochloric, pure hydrochloric acid, but in the form of liquid, not in the form of gas, but it's in the form of, like you are great, now. That's it. So we got, so the whenever you are writing a chemical reaction, you have to indicate there is a liquid, solid. Here NaOH is not a solid. Simply written here, don't mistake me.